everyone. In this video, we're going to use the Multibody library to create a 2-mass, 3-spring system and then use the Modal Analysis App to get the natural frequencies of the system. So I'm going to begin by adding my bodies and frames. So I'm going to add 2 bodies representing my masses, as well as 2 fixed frames, which are going to represent my rigid or my fixed ends. I'm then going to go to joints and motions, and I will bring in prismatics, and I'm bringing these in to restrict the motion in a 1D sense, as well as to introduce kind of that spring component. There is a parameter on the prismatic that allows me to specify that. To keep things simple, I will just have the same values for the masses and the spring constants, which I'll put in a parameter block. So for M will be my mass, K will be my spring stiffness, and I will just set this to 10, as well as I'll have an unstretched length for my springs, and I'm just going to set this to 0.2. Nothing specific or special about this number, just a number. I can pick my various components all at once, set that stiffness value, the unstretched length. No damping in this model. For the masses, I will just set the value to M. To initialize everything correctly, I will place everything along the x-axis. This fixed frame will be 3 times the unstretched length away, of course measuring from the left end here. And then these masses I'm going to initialize, strictly enforce this, and the first one will be 1 unstretched spring length away, the other one will be 2. And then what I'm going to do is I'll give one of these, I'll give this one just a small initial velocity. Maybe I'll do it just ½ meter per second in the x direction. So I can run a simulation. What I want to see is that everything is initializing correctly, that we see everything kind of moving back and forth as you would expect if you had some springs in your system. Because it is 1D, I'll just change the view to be this one. Right, so we can see, right, there's no graphical representation currently, but you can imagine that there are springs between these fixed points here. Now that we've created this system, we can actually use the Modal Analysis app to determine what our natural frequencies are. So go to the app section, Model Analysis, and we'll go to Modal Analysis. We'll open it up, and we're just going to click on Analyze Models, and it's going to just link to our system, bring in all the equations, and it's going to determine what the natural frequencies are for us. There are only 2 degrees of freedom, so the first one here we see is at 0.5 hertz, the second one at 0.87, and we can actually double check these values knowing the expected equation or the expected expression for the frequencies. So we'll minimize this, open up a worksheet. This is going to attach a Maple worksheet which allows us to do calculations. In this case I don't need to connect to my model, so I'll just delete this line. And really all I need is to just perform a calculation. So I'll set K equal to 10, which was the value I had entered in the parameter block, and M will just be 1. And the expressions are known. The first frequency, or the first natural frequency, is K over M. And this is of course in radians per second. So what I need to do is actually divide by 2 pi. So we see it's 0.5, which is what we saw in the app. And the second one is just 3 times K over M, which is 0.87. And so we can actually see that MapleSim was very easily able to get the natural frequencies for us. So let me just bring it here. Right, so the first one 0.87, and then the second one, or the first mode being 0.5. So this is how you can actually build a model and without much effort get MapleSim to grab the natural frequencies of the system for you.